So in this video, I'll explain the data preparation, data visualization, and other tools. I'll write and the collapse for the tabular diverse data set and the time series. Where in this, I'll be using the New York taxi, and for time GPT, I'll explain what I'm using. Uh, for downloading the data set and uploading my files as a JSON file, and post that these all the downloading the data set, unzipping the data set, and these are the importing libraries one, and here is the loading data and information of the data set, and post that these are the total columns present in my data set, and I have installed the switzy, and from switzy I have shown the HTML report showing that what all there in my data set, and posted these are the performing the missing value heat map, and this is the distribution of air BNB listing prices versus, and these are the figure price distribution of the neighborhood groups, and this is all about the price distribution and neighborhood groups in different categories, and here I'll be performing encoding and feature selection part. So this is the encoding category variables where I perform the room type using the label encoding, and post that here is the standardizing normal features, for that the scaling numerical features for that, the scale fit transforms and the price medium and then number of reviews, like that. And here is the insertion of feature selection and um, correlation heat map for the feature selection. This is the correlation heat map, and here I perform the clustering and anomaly detection. So this is the anomaly detection with isolated for forest, and this is the output I received for the anomaly detection, and this is the model building. I built a train and test models like this, and post that this is the defining interpolation and missing values I just cross checked here, and this is the how much linear regression performance R square and RMS squares, and this is a random forest, and this is the gradient boost. So I'll compare all these things, and as a random forest was giving better results, so I run the whole fitting part in this, and here is a random forest regression that computed, and here is a feature engineering part for this, and here is a clustering part for that, and here is the visualization part after the anomaly detection isolation forest. So here is the two plots for that, and this is the for the anomaly detection data points, this is the data set after removing, and sizes of data set isolated forest and loft. So these are the there is no difference in between these two data sets. So here I'll be performing AutoML and AutoVML analysis. So here is the so what all things we did above, it's like a repetitive process in a less number of code. So this is the entire code that will predict the models and do the better fit models, model training and all best will be performed here, and here is the best model for that, and here is the selection features and the features of that. So this is the overall EDA detection and removing clustering anomaly detection and all part has been performed, and even AutoML and AutoVML has been performed here, and this is the output for that. And leaving that, the second assignment is how to perform basically the same steps with the time series with a different data set. So here I took the traffic regression and traffic basically air traffic data, so passenger traffic data. So I didn't download any data, directly I read from the loading passenger from the GitHub, and this is the one way of loading the data and the preview of the data, and here's the basic statistical analysis and checking the missing values and time series visualization for this, and here is the decomposition time series where it has all seasonality trend and other residual following that, either we can fit the arima or sarima, to understand that. So we need to do these kind of things like trend, seasonality and reduction, and average passengers per month, and anomaly detection and plot anomaly highlights, and post that here I did the clustering part and just scaling the features up k-means to it, and post that visualization of a clustering part and a prediction part, where these are the cluster 0, cluster 1 and clusters 2, and this is a correlation heat map, and post that this is a Sarema forecast versus actual and predicted one. It has a very good forecast, while the training and test data has been showcased in this preview, and post that evaluating a model, like I got main score of 59 and etc etc. So these are the values, and experiment with the advanced model. Here is a I performed for that, and for cross validation, and these are the cross validation steps, and combining the forecast and ensemble model code is here, and investigating forecast intervals. So for the training, for the test data and the forecast data, it both has the exact same prediction. Like the model performed well. So here is some I find out some typo errors, like it was there for my collab or something. So I was trying to reinstall the SciPy and change the runtime SciPy version to 1.7.3 from the latest version. Then the auto VML ran. So these are the kind of trial and error steps where I performed for this. And the data cleaning step was this: to understand the data, like where I'm getting error, I kind of tried all the different ways to understand what's happening inside the data and why I'm getting error. So I have performed all the errors. So here is the seasonal output of that, and here is a missing value imputations, and post that, like from auto VML, like I have performed the model, like here is a regression matrix plot for the ensemble model, and post that here is output for that, like